Hello friends, and welcome back to Auto Fix Zone. We all know that a faulty engine coolant temperature sensor can cause incorrect coolant fan operation or make the temperature gauge suddenly drop out. But did you know that the very same sensor can also affect AC compressor operation, automatic transmission shift strategy, fuel consumption, and even more unexpected symptoms? In this video, we're going to discuss 6 unusual and often overlooked failures that can be traced back to a $5 sensor, a component that appears simple, yet in reality plays a critical role in controlling nearly half of the vehicle's operating strategy. Let's get started. Number 1. Extended crank or no start condition. A delayed start or a complete no start can have multiple causes. The most common include lack of fuel delivery to the injectors, no ignition spark, a failed crankshaft position sensor. However, it's rarely suspected that the coolant temperature sensor could be responsible. Here's why. During cold starts, especially in low ambient temperatures, the ECU relies heavily on ECT input to determine cold enrichment strategy. The sensor should report a coolant temperature close to ambient temperature when the engine is fully cold. If scan data shows a coolant temperature reading significantly lower than ambient, particularly a fixed value such as -40 degrees Celsius, this typically indicates an open circuit in the ECT signal. As a result, the ECU overcompensates or miscalculates injector pulse width, which may lead to extended crank time or even a no-start condition. We've previously covered complete no-start diagnostics, cold start delay, and hot soak restart issues in separate videos. Links are available in the description below. Number 2. Increased fuel consumption. Excessive fuel consumption is commonly attributed to faults in components such as mass airflow sensor, oxygen sensors, or fuel injectors. However, the ECT sensor plays a fundamental role in fuel delivery calculations. During cold operation, the ECU commands a richer air-fuel mixture to stabilize combustion. As engine temperature increases, the system transitions from open-loop to closed-loop operation, relying more heavily on O2 sensor feedback. If the ECT sensor falsely reports a cold engine condition, the ECU may remain in open-loop enrichment longer than necessary, increasing injector pulse width and fuel consumption. Incorrect temperature input directly affects fuel trim calculations and overall combustion efficiency. We've previously published a full breakdown of fuel consumption causes, link in the description. Number 3. Sudden engine stall or limp mode activation. If your engine suddenly stalls without warning, one possible, though often overlooked cause is loss of ECT signal. In certain vehicle platforms, if the ECU detects implausible or missing coolant temperature data, it may initiate a fail-safe strategy, which can result in immediate engine shutdown as a protective measure or activation of limp home mode. In limp mode, engine power and RPM are limited, and vehicle speed may be restricted to approximately 40 kilometers per hour, depending on manufacturer's strategy. This is designed to prevent potential overheating damage when accurate thermal data is unavailable. Number 4. AC compressor inhibition. In some vehicles, if coolant temperature data is implausible or outside expected parameters, the ECU may disable AC compressor engagement. Why? Because the ECU cannot confidently determine engine thermal load conditions. To prevent potential overheating under additional compressor load, it may inhibit AC operation entirely. This issue is often misdiagnosed as low refrigerant charge, faulty compressor, or pressure switch failure, when in reality, the root cause is inaccurate coolant temperature data. 5. Delayed or erratic automatic transmission shifts. On vehicles equipped with automatic transmissions, shift timing strategy is influenced by engine operating temperature. When the engine is cold, transmission control logic may delay upshifts, hold higher RPM, modify torque converter clutch engagement. If the ECT sensor falsely reports a cold engine condition, the transmission may remain in a cold shift strategy longer than intended. The result? Late shifts, elevated RPM, sluggish acceleration, and a restricted or hesitant driving feel. Shift scheduling differs significantly between cold mode and normal operating mode, and inaccurate temperature input directly disrupts this calibration. 6. Reduced engine power at normal operating temperature. Once the engine reaches normal operating temperature, the ECU adjusts fueling and ignition timing for efficiency and performance. However, if the ECT sensor falsely reports an overheated condition, the ECU may reduce injector pulse width, retard ignition timing. This can lead to noticeable loss of torque and reduced engine output, even though actual coolant temperature is perfectly normal. All of this can be caused by a failed $5 temperature sensor. If you found this video helpful, make sure to like the video, subscribe to the channel, and enable notifications so you don't miss future content. You've been watching Auto Fix Zone. I'll see you in the next one.